There are different strategies used in prompt engineering. One of such strategy is splitting complex tasks into smaller subtasks. In this video, we are going to use a real-world use case, log analysis using language model. While implementing this use case, we will learn how to split a complex task into subtasks to implement this use case. So without further ado, let's dive into this lesson. Just as it is a good practice in software engineering to decompose a complex system into a set of modular components, the same is true of tasks submitted to a language model. Complex tasks tend to have higher error rates than simpler tasks. Furthermore, complex tasks can often be redefined as a workflow of simpler tasks in which the outputs of earlier tasks are used to construct the inputs to the later tasks. Therefore, for tasks in which lots of independent sets of prompt instructions are needed to handle different cases, it can be beneficial to first break that into smaller tasks and have task-specific instructions as needed. The advantage of this approach is that each query will contain only those instructions that are required to perform that subtask, which can result in lower error rates compared to using a single query to perform the whole task. This can also result in lower costs since larger prompts cost more. And last but not least, this approach also helps you remain in context limit of the language model. Let us try to understand this with a real-world example use case. Imagine you are monitoring a system comprised of two applications named application ABC and application XYZ, each interacting with two databases, database ABC and database XYZ. Both applications and databases are generating logs that are critical for monitoring this entire system's health. These logs contains critical information like errors and warning messages along with alarms, KPIs, and counters. To ensure that system is healthy, we need to analyze these log files regularly. Now, analyzing these log files can be a tedious task, which can be streamlined through automation by leveraging a language model with prompt engineering. Here is how you could set it up. So gather all logs from application ABC, application XYZ, database ABC, and database XYZ into a single repository. Then create a prompt instruction instructing the language model to analyze these logs for health monitoring. And finally, evaluate the response generated by the language models. Okay, so let us try to implement this in real code. This is our Jupyter notebook on Google Colab, which we are going to use for this lesson. First thing we need to do is to create the setup. So we are going to install OpenAI libraries because we are going to use OpenAI APIs and GPT 3.5 turbo model. So library is being installed. Now we need to import the needed libraries. We are using OpenAI API and their model. Therefore, we need OpenAI API key. If you do not have your API key, you need to create your account on OpenAI and generate your API key first. You can search on Google how to generate OpenAI API key and you will get the required information. I have generated my OpenAI API key and configured it inside Google Colab Secrets. So this is Google Colab Secrets where you can configure multiple keys. So this one is my OpenAI API key. And here, once you configure your OpenAI API key inside the secrets of Colab, you can import this library and then call userdata.get function and get your API keys from the secrets. So here in my secret underscore key, now I have my OpenAI API key. Now we need to initialize a client for interacting with the OpenAI API. So this line of the code is calling the constructor of the OpenAI class from OpenAI library. The constructor creates a new client object that can communicate with the OpenAI API. Here, API key equals my secret key This is the parameter in the constructor where you provide your API key. Now I have this helper function, getResponse. GetResponse is designed to interact with the OpenAI API to get response from a language model, specifically GPT 3.5 Turbo. So this getResponse takes one parameter called messages. This parameter is expected to be a list of message objects formatted according to the requirements of the OpenAI API. This block of code is where the function interacts with the OpenAI API using the client object. Here model equals GPT 3.5 Turbo specifies which model to use. So here it is using GPT 3.5 Turbo, a version of OpenAI's GPT-3 model optimized for chat-like interactions. Then messages is basically passes the list of message objects to the model. These messages contextualizes the conversation of the model. Then max tokens, which is configured 2000, which is 2K, sets the maximum length of the response. So the model will generate up to 2000 tokens in its response. And finally, this temperature controls the randomness of the output. A lower temperature, like we are setting 0.2, results in more deterministic and less random responses, making them more predictable and conservative. And finally, this function returns the response from the GPT 3.5 Turbo model. Now, this is our sample log files. So this is the log snippet for application ABC. Similarly, we have log snippet for application XYZ. Then we have log snippet for database ABC. And finally, we have log snippet for database XYZ. So let us keep executing this code while we are moving further. Let us initialize this log snippet in the respective variables. Okay, now let us merge all these logs in one variable. So this log file content is a variable where we are merging all the log contents. So this is how the merged log content looks like. So it has all the 4 log snippet merged into one variable. So now let us define our prompt. So this is our instruction prompt, so which we are going to configure inside the system prompt for GPT 3.5 Turbo model, where we are saying that you will be provided with a log file which contains logs for applications ABC, XYZ, database ABC, and database XYZ. Your task is to analyze the log and summarize the errors. Okay, now, so we are creating a list. Now inside this messages list, we have appended the system prompt, which is this instruction that how model need to analyze this particular log file, and then we are passing the log file inside the user prompt. Now we will call our getResponse function. This getResponse function is where we are now going to pass this list which we have just initialized and then see the response from the model. So this is the response from the model. It says that based on the provided log data, here is a summary of errors encountered in each application and database. So here we can see that for application ABC, what all the errors were there in the log file, it captured those errors. Similarly, for application XYZ, it captured all the errors were there in the log file. And similarly for database ABC and database XYZ. Now, looking at this response, say you feel that this is not good enough and you need more detailed response. So let us try to improve our prompt instruction. So now what we are doing here is, you see in the earlier prompt, we said your task is to analyze the log and summarize the errors. Now we are improving our prompt because we wanted to capture some more in our analysis. So here we are improving our prompt saying that your task is to analyze the log and summarize key events, especially errors, and warnings. So far, we had instructed only to capture the errors, but now we are instructing the language model to also capture the warnings. Let us initialize this messages list, and then again call get response. Now we can see in the response for application ABC, along with errors, now it has also captured the warnings. Same goes for application XYZ. So along with errors, now it is also capturing the warning messages from the log file. Same applies for database ABC and XYZ. Suppose you realize additional application specific nuances need to be addressed. Like in your log files, you saw that just capturing the warning messages and the error messages is not good enough. You also want to look into the actual log content. Say, I want to see what is the response time when application is trying to access the database. Is there any delay? Is there any disconnection happening? So to capture such nuances, you need to improve your prompt instructions. You need to add these specific instructions into the prompt so that language models can follow those instructions to capture those nuances from the respective log file. Now, to do this, you cannot simply append more instructions due to the inherent constraint of language models, namely the token limit. So language models such as GPT-4 or any other language models, Llama or Mixtral, have a maximum token limit for processing inputs and outputs. When your prompt instructions grow too long, including the logs, they may exceed this limit. As you expand your prompts, the model's fixed size context window might cause it to lose track of earlier parts of the discussion and therefore leading to context drift. If the input surpasses token limit threshold, the oldest information is forgotten. Now, to mitigate this, a strategic approach involves breaking down the complex task into smaller, more focused subtasks. Therefore, the problem which we have in hand, the log analysis, now we can create a strategy where we can develop distinct application specific prompt instructions and then feed the language model only with the relevant application specific log and corresponding prompt instruction. By doing so, you ensure that the language model's analysis remains detailed and within the operational limits, allowing for a more precise health monitoring of your system. This breakdown clearly explains the system configuration, the role of prompt engineering, and language model, the challenges involved, and the strategic solution. Let us improve our code to split this log analysis task into smaller subtasks. So here we have defined 4 different prompts. So now one prompt for application ABC, where we are saying that your task is to analyze log file for application ABC using below instructions. And under instructions, we are saying that use report name as health analysis for application ABC, capture the time when database connection initiated, capture the time when database connection failed, capture how many times database connections was retried along with time of retry. Highlight if there was any network fluctuation, also capture the time. Highlight if response time of database ABC is more than 100 milliseconds. So now we are trying to capture all these nuances from the log file for application ABC. Similarly, we have defined the prompt instructions for application XYZ. We have defined separate prompt instruction for database ABC and separate prompt instruction for database XYZ. And then finally, we have prompt instruction to generate the final summary, where we are saying you will be provided with set of system health report analysis, and your task is to summarize the analysis. Under instruction, we are saying use report name as summary of health analysis. So let us initialize these new prompts. Okay. Now remember, in the beginning, we have different log snippet assigned to different variable for application ABC, then for application XYZ, then for database ABC, and for database XYZ. So we are not going to merge them. We are going to use them individually because now we have created our individual prompts. Okay, so now we are here. We are initializing a message list, and in a similar way, we are just appending in the message list the system prompt or the instruction for application ABC, and we are appending the log snippet for application ABC. So this combination, like the prompt instruction for application ABC and log snippet for application ABC, is now assigned or added in this message list. And then we are calling the get response function, passing this message list, and this message list contains the instruction prompt for application ABC and the log snippet for application ABC. And whatever response we are going to get from this get response function, we are going to store in a temporary variable called analysis for application ABC. So let us run this block and see the response. Great. So now we can see the instruction, whatever we provided to capture specific nuances from the log file. This language model is able to follow our instruction and capture those. Now, similarly, let us run this piece of code for application XYZ. So here we are passing the prompt instruction for XYZ along with the log snippet of XYZ, and here is the response. Similarly, we can run for database XYZ and database ABC, and now for database XYZ. Very well. Now all these responses were stored in separate variables, you see. Now what we're doing, basically, we are going to create a variable called all analysis, and in that we're going to merge all these analysis which was generated by the language model. Okay, now we are going to call get response once again, and this time we are going to pass the instruction prompt for generating final summary, and we are going to pass this all analysis. This all analysis is basically nothing but the individual analyses merged together. So if you want to see, so this is the individual analysis merged. So all these four analyses are merged into one variable, and now we are passing this as part of final summary. And this is the final summary generated by the language model. So here you can see summary of health analysis, and then for application ABC, XYZ, database ABC, and database XYZ. So this is how we have broken down our complex task into subtasks, executed subtasks individually, and finally brought them together as part of the final summary. Okay, so just putting everything together. So here we defined a dictionary containing log files, content, and corresponding prompt. So whatever we have achieved here, now we're going to put everything together just to have a very clean application. So this dictionary, you see, the log files is basically having the entry for every application. For every application, there is a chunk which is nothing but the log snippet and the corresponding prompt. Then we have this result list. So this result list is where we store our intermediate responses and finally use this for summary. Here we have two helper functions. One is analyze log files, and the second one is create summary report. This line of the code is defining a function named analyze log file, where it takes one parameter called log files. This parameter is expected to be a dictionary, which we just defined above, where each key is a unique identifier, which is the log ID for a log file, and its value is another dictionary, like the details, containing the specific data which is needed for the log analysis, which is basically the log content, we call it chunk, and the corresponding prompt instructions. Now, this line starts a loop over the dictionary log files dot items. So this dictionary log files dot items is a method that returns a list of tuples pair, like key and value pair, from the dictionary. Here, log ID is the key and details is the value, like another dictionary. Then we have these messages as talked earlier many times. So this messages is basically initializes an empty list to store messages that will be sent to the model, and then the messages dot append where we are having our system prompt. So basically this adds a message with the role of system, which usually represents instructions or contextual information or our prompt instruction, and the content of this message is taken from the details prompt, which should contain the prompt or the context for the log analysis. And then the second message dot append where we are appending the user message is basically adds another message to the role of user corresponding to an input from the user, which is the chunk or the log snippet. And the content here is the detailed chunk. And then it is calling this get analysis function, which was defined earlier. And then it is appending the result into this result list. So now you can see this for loop will run basically 4 times because we have 4 elements or items in this dictionary. So one for application ABC, one for application XYZ, then for database ABC and database XYZ. And eventually, this result will contain those 4 responses from the language models. When that is done, then we have this another helper function. What it does is basically it generates the final summary. This function takes 2 parameters. One is the result list, where all the individual results were stored, and then the summary prompt. This line concatenates all the string in the results list into a single string called analysis result. Each string is separated by a space. So this provides a complete text that comprises all individual analysis outputs, which was done before. Then again, we have this empty message list. And in this message list, we are appending system prompt and user prompt and calling the get response function, passing this list, message list, and then we are getting the final response. Now let us initialize this piece of code and execute them and see the outcome. So the outcome will be similar to what we already got, but this is just kind of putting everything together. So here you see we are getting the individual analysis. So this is for application ABC, then for application XYZ, we may get also for databases. So let us see. Yeah, so this is for database ABC and finally database XYZ. And then finally, we will call our create summary report. So this will just take all those individual analysis and create this summary. So this is the final summary of the log analysis. Okay, so great. This is how we have splitted our complex task log analysis into smaller subtasks and implemented our log analysis application. Great. So before we end, here is a small tip. So as I mentioned that every language model has input token limits. Therefore, it is a good practice to always count the input tokens before making the call to the language model. So this library, tick token from OpenAI, helps you do that if you are working with their model. So this is a small helper function. It basically count underscore tokens, which takes the input text, and using this tick token dot encoding underscore for model, and where you basically pass this GPT 3.5 turbo. So using this encoding scheme, it basically counts the number of tokens in the input text. So we first need to install this library. Then you need to import this library and let us initialize this helper function. And now let us call this count underscore tokens, and this we are now passing this log underscore file underscore content. Remember this variable where initially we merged all those 4 log snippet into this variable. Now if we pass this, so this is what exactly it is saying, that this text contains 5265 tokens. Okay, great. So this is all for this lesson, and I shall share the link of this notebook in the description of this video. Thank you.